go to the question number 6 in the tute given to you. I'll start with question number 6 because there are some other questions which are easy for you. So I will start with this part of the lesson. I don't mean that this is difficult, but then we were not able to discuss a question like this before. So we'll go to this. Polychloroethane is a polymer. You may not understand what this means, but just imagine it's a substance, it's a polymer, something like plastic. It is made from its monomer, chloroethene. Simply understand this compound, this substance is made by another compound called chloroethene. That's not our concern. Our concern is this. Chloroethene has a percentage composition by mass, carbon, hydrogen, and chlorine. Their percentage values are given. Show by calculation that the empirical formula of chloroethene is C2H3Cl. We have to find out empirical formula. If you have forgotten, empirical formula is a simplest ratio of different types of atoms. Different types of atoms present in a molecule, let's say. Empirical formula is the simplest ratio of different types of atoms or different atoms present in a molecule. Okay, fine. With this definition, if you remember, whenever you do a calculation of this nature, empirical formula calculation, we have to construct a spreadsheet. In the spreadsheet, first we have to write the type of element present. What are the elements present? And then we have to write the mass of each element. Afterwards, we go to moles. And finally, we go to mole ratio. This is the order in which we go ahead. And first we'll see the elements present. What are the elements in the compound? Carbon is there. It's one element. Hydrogen is the second element. Third element is chlorine. While listening and observing, you can copy down this because it's easy to do the lesson in that manner. Plus, we can finish it quickly. Okay, I have written the different types of elements present. Now to write the mass. What are the mass values of each element? The question says the mass of carbon is 38.4. And the mass of hydrogen, it is 4.8. Finally, we have the mass of chlorine, it is 56.8. Now we know the mass values. After the mass, we need to calculate the moles of each element. To find the moles, what we have to do is, we have to divide each mass. Now this one we have to divide by its molar mass. What's the molar mass of carbon? It is 12. Now we go to hydrogen. Hydrogen mass is 48. It has to be divided by its molar mass, let's say 1. You can get these values from the periodic table, you know how to do it. And then we go to chlorine. Chlorine mass is 56.8. If you divide this 56.8 by 35.5 in the periodic table, you can find out these values. Now we have to divide mass by molar mass to get the number of moles. I will write it in red. Here, when you divide 38.5 or 4 by 12, you can take the calculator and do this work. Here we have 3.2. 3.2. 4.8 divided by 1 is 4.8. And 56.8 divided by 35.5, we can do it with the calculator. Okay, here is my calculator. We have 56.8 divided by 35.5. The answer is 1.6. Once you get the mole values, these are the mole values, we had to find out the ratio of moles. To find the ratio of moles, again, it's an easy thing. We divide everything by this smallest mole now. What is the smallest value for a mole here? 3.2, 4.8, 1.6. You divide everything by 1.6. When you divide everything by 1.6, I get the values here. I'll use a different color for that, probably blue. Yeah. 3.2 divided by 1.6 is 2. 4.8 divided by 1.6 is equal to 3. 4.8 divided by 1.6, it is 3. 1.6 divided by 1.6 is equal to 1. So the ratio of carbon to hydrogen to chlorine is 2:3:1. That is exactly what the question is asking you to find out. See whether it is this. Yeah, we have got it. So carbon 2, we can write C2. Hydrogen 3, H3. This question is made easy for you by telling what the empirical formula is. At times, the answer is not given. You have to simply calculate the answer. And we don't know, even if you make a mistake, you don't know if you have done it. But this question is easy because answer is given and we do the working to get the answer. Yeah, that's right. We have done it. I hope you have copied now. And afterwards, we go to another question. I have taken it as part B. Can we go to that? C. Magnesium nitrate crystals contain water crystallization with the formula MgNO3 twice dot 6H2. And don't get scared with this term, crystallization water or water crystallization. What is the water crystallization? If you take crystals of any ionic substance, always there are some water molecules. In magnesium nitrate, 6 water molecules are there. In different other soils, this number of water molecules may change also. It's not a fixed value. It changes from one compound to another compound. For example, you have heard copper sulfate. If you take copper sulfate crystals, we have 5 water molecules in them. H2O. And I think one more. Sodium carbonate. This is sodium carbonate. Sodium carbonate has 10 water molecules. These water molecules are called crystallization water. Now, in this question, we have magnesium nitrate. Magnesium, now this should be 3. Yeah, bracket outside 2. Magnesium nitrate. Dot, how much of crystallization water is there? 6H2O. Now, if you investigate further into this, what is the meaning of copper sulfate dot 5H2. I'll write simply, there are 5 water molecules. There are 5 water molecules attached to one CuSO4 unit. If you take one copper sulfate unit, you have 5 water molecules attached to it. Similarly, I can write for the next one also. There are how many water molecules? There are 10 water molecules. 10 water molecules were attached to one Na2CO3 unit. In one Na2CO3 unit, there are 10 water molecules. Likewise, when you go to the last one, there are not 5, this time there are 6 water molecules attached to one magnesium nitrate. Try to understand this first. Now, again, remember, what is the meaning of these water molecules? 5 or 10 or 6, they are called crystallization water or water of crystallization. We have questions in our papers to find out crystallization water. How many water molecules are there with one copper sulfate? How many water molecules are there with one sodium carbonate? How many water molecules are there with one magnesium nitrate? Likewise, we have calculations. We will see what the first question is. Even though I explained this to you, the first question is something very simple. Show by calculation that the relative formula mass of magnesium nitrate dot 6H2 is 256. Now see, this question is also made easy for you. How? The question is giving you the answer. We can simply do the calculation and see whether we can get this. Okay, now we have to find out molar mass of sodium sulfate. I take this magnesium nitrate. I take magnesium nitrate dot 6H2 aside and try to find out the relative formula mass. To find the relative formula mass, we have to see how many different types of atoms are there in this molecule. For example, magnesium. Magnesium, how many atoms are there? Only one. So I write magnesium into 1. And we go to nitrogen. How many nitrogen are there? Nitrogen number is 2. Because here, in this NO3 part, we have 1 nitrogen. Outside the bracket, you have 2 means NO3 2 times. So there are 2 nitrogen. And afterwards, we go to oxygen from here. Oxygen present over here is 6. 3 into 2 is 6. So I can write oxygen into 6. Oxygen comes afterwards also, but then I take oxygen in this manner. It's easy. And then how many hydrogen are there? Hydrogen, there are 12 hydrogen because there are 6 water molecules here. 6 water molecules. 1 water molecule has 2 hydrogen. So 6 water molecules have 12 hydrogen. Plus, again, we have oxygen. How many oxygen are there? Oxygen, there are 6 oxygen. Now we have to find out the mass of each. Magnesium mass from the periodic table, we can find out it is 24. 24 into 1. 24 into 1 is 24. Just 24. We go to the second one. In the second one, there are 2 nitrogen. 1 nitrogen is 14. Into 2, it is 28. I hope you get the idea. In the next one, we have oxygen 6. One oxygen is 16 into 6. How much is it? It is 36, 96. I think I'm right, 96. Yeah, you can get the calculator and see the calculation. Hydrogen 16 means 1 into 6. Hydrogen 12. 1 into 12. So that gives me 12. Again, oxygen comes. Oxygen 6 means 16 into 6. It is again 96. Now we have to get the total mass. Total mass is equal to 24 plus 28 plus 96 plus 12 plus 96. 256. There I get the answer, 256. Is it the same as what the question is asking? Yeah, here it is 256. You got the answer, 256. Your question gives 256. I also calculated 256. So answer is done. Shall we go to the next question now? I can remove this answer for question number 1, A, part A. Empirical formula calculation, I'll remove it. In fact, I can remove the whole question because we don't want it anymore. I'll take the whole thing up a little bit so that the question that we have worked out is gone. Even this description I can remove. I hope you have copied down this. This is not good. Yeah, this is where we are. And again, magnesium nitrate mass we have found out to be 256. We go to the next one. Show that the maximum mass of magnesium nitrate, 6H2O, that could be made from 0.05 moles of nitric acid is about 6 grams. To do this work, we should know the balanced chemical equation. So I write the chemical reaction between what I want to make magnesium nitrate. Show that the maximum mass of magnesium nitrate that could be made from 0.05 moles of nitric acid is about 6 grams. Okay, the equation is this. Magnesium, I think I have to change the black or blue. Blue is better. Magnesium. Magnesium can react with nitric acid, which is HNO3. Formula of magnesium nitrate is given, is not easy for us. It's not difficult for us. Okay, magnesium nitrate. Twice. How do you know it's twice? Because in the question, formula of magnesium nitrate is given. Plus, we have hydrogen gas. When a metal reacts with an acid, hydrogen gas is given out. You have learned this in earlier grades. Now to balance the equation, I write 2HNO3. Right, this is a balance equation. Now this is going to be a stoichiometric calculation as I had taught in the class. Question was to find out whether 6 grams of magnesium nitrate is formed when 0.05 moles of nitric acid is used. The question is about HNO3 and magnesium nitrate. If you look at the the balanced chemical equation, 2 moles of nitric acid produces 1 mole of magnesium nitrate. I think it's not difficult to understand because this 2 is given in front of nitric acid. That means nitric acid 2 moles react. It produces magnesium nitrate 1 mole. So under magnesium nitrate, I wrote 1. If nitric acid 2 moles produce 1 mole of magnesium nitrate, in this question, nitric acid 0.05 is given. If you use 0.05 moles of nitric acid, can you figure out how many magnesium nitrate will be produced? Ratio is 2:1. The amount of magnesium nitrate formed is half of the nitric acid. It's seen here. 2 moles of HNO3 produces magnesium nitrate 1 mole. Therefore, 0.05 moles of nitric acid here written on the left-hand side. 0.05 moles of HNO3 will produce how many magnesium nitrate moles? I make it X. It's a simple cross multiplication now. We can multiply 2 by X and 0.05 by 1. I write it here. 2x. 2x is equal to 1 into 0.05. You get it? And then x is equal to 1 into 0.05 means still 0.05. We have to divide this by 2. So you get the answer for x 0.025. 0.025 moles. What is it? 0.025 moles of magnesium nitrate. Zero point 0.025 moles of magnesium nitrate. However, the question is not asking about magnesium nitrate moles. Question wants you to find out the mass. I do a line over here to separate the working, and I go to the next one. There's a formula. I don't know if you remember. Mole is equal to what is equal to mass. Mass over molar mass. Question doesn't want the mole, question wants the mass. So I rearrange this and write mass is equal to moles into molar mass. I think moles we have found out. Yeah, moles are there. But the mass is equal to moles. Moles means 0.025 into what's the molar mass of magnesium nitrate? We calculated earlier 256. 256. Now we'll multiply 265, 56. 256. We'll multiply 256 by 0.025. 250 into 0.025. The answer is going to be 6.4. Now that's fine because the question is asking your answer is going to be about 6. not 6, about 6. So this about 6 I have calculated to be 6.4 is something nearer to 6, 6.4. What is the meaning of this 6.4? It is the mass of magnesium nitrate. I'll write in words. Mass of magnesium nitrate that can be formed. There's something like we expect this 6.4 grams to be produced in the experiment, according to the calculation. 6.4 mass of magnesium nitrate that can be formed. Okay, remember, look at this clearly. If you carry out this experiment by using 0.05 moles of nitric acid, we are supposed to get about 6 grams, means I calculated to get 6.4. That's the maximum I can get. Next question is asking, the actual mass of crystals that the student obtains is 4.8. Now what is it? I'm supposed to get 6.4. But I'm getting how much? 4.8. Now calculate the percentage yield of magnesium nitrate. Percentage yield of magnesium nitrate means, I can write like this. Magnesium nitrate. Magnesium nitrate percentage. We call it yield percentage. Magnesium nitrate yield percentage. We can carry out this calculation easily by using this formula. We can write mass obtained into 100, because we are calculating percentage. Mass obtained into 100 divided by mass expected. Mass expected. Now I'll write it on the right-hand side. Then we do a line to separate this calculation part that we have already done from what we are going to do now. Okay. Here we have magnesium nitrate yield percentage is equal to what is about mass obtained. The question says how many grams have been obtained. How many grams obtained? 4.8. 4.8 into 100 divided by, we have to write how much we expect. We expect 6.4, but we are getting 4.8. So what's the percentage yield? Percentage yield we can calculate 4.8 into 100 divided by 6.4. Answer is 75. Percentage yield is 75. That means you don't get 100% yield. According to these calculations, we get 75% of magnesium nitrate crystals. This is the answer. Children, if the session finishes, you have to come back using the same link because this is a recurring meeting. Copy down the answer, not just for the sake of copying. While reading the question, try to get the idea as to what I have to do and what we have done. Step by step analysis must be done. Okay, have you finished this work? Can I go to the next question? Please tell.